assembly line balancing, scaling up. So suppose now it's August and the demand has increased to 700 scooters per week. Remember before, in March it was 125, then in May it was 200, now it increased to 700 scooters per week. What are the possible solutions? So we can do several things. First of all, of course, we cannot just balance the assembly line anymore. We have already balanced it as much as possible according to the tasks that we have. So we can do several things. We can, of course, we need some investment, like we need to hire more workers or do something else, like overtime at least. One solution would be to have 4 assembly lines working in parallel. So just copy the line that we have. Remember, the balanced line has 189.5 scooters per week capacity. If we need 700 demand satisfied, it would take, right, if we had 4 lines, we could cope with it because 700 over 189 gives us 3.69. So 3.69 lines is not possible to install, but we can round this up to 4 and have 4 lines to produce enough scooters, right? 4 lines would have 4 times 189.5 scooters per week capacity, and that would be sufficient to satisfy demand 700. An alternative would be to have 3 lines, and then this 0.69 that we're kind of short of, right? We could have an overtime, so maybe we could ask the workers to work more, right? We could calculate exactly how much more we would need from every line, right? This you could take 700 over 3 to find out that the demand required from each line, and it could give you an idea how much more time is necessary for each of the 3 lines if you want just 3 lines. Of course, the advantage of this would be that there is fewer workers we need to hire, and overtime might be necessary only temporarily, right? So we might have this benefit of not hiring too many workers in case in the future we need to scale production down. Another solution number 3, would be just keep one line, but have multiple workers at each step, right? And because this is an assembly line where we have some inventory here between the stations, this is still possible, right? After each of those workers works separately on a separate scooter and just moves them to this inventory. So just there would be maybe more inventory in general in the same location, right? This is a little bit a variant of the first solution, right, where we had multiple assembly lines, but basically combining these inventories in between. Another solution would be a higher worker specialization, basically saying I still have 4 times the number of workers. So instead of having 3 workers, I will have 12 workers. But now I will organize them sequentially and give each worker some tasks, right? But much fewer tasks to complete one scooter, right? So now this assembly line, instead of having 3 stations, would have 12 stations, each station with 1 worker on each. And this is showing graphically the division of tasks among workers. And it happens that when it is actually quite, it is possible to divide them quite equally, right? There is some imbalance, but because these are these are discrete numbers, we have to put 1 task or 2 tasks or 3 tasks for every worker, such that the maximum is kept as low as possible. In this case, the maximum is 180 seconds per worker, and the bottleneck is worker 2, right? So the cycle time is 180. The smallest cycle time we can work with is 180 seconds per scooter or 3 minutes per scooter. So our capacity can be 1 every 3 minutes. Converting it to per week, it gives us exactly 700 scooters per week, which is, it happens, right? By chance, it happened that it is exactly matching the demand per week. One more solution could be that we would have parallel cells. We would just say each cell is operated by the same person performing all the steps, right? So we could also go for this solution. as an alternative.